Welcome, traveler of the night. Wherever you are, let the day drift softly behind you. Breathe in the quiet vastness above. Breathe out the weight of all that has been. Tonight, we journey through the deep, not of oceans, but of stars. Imagine a sea without waves, a horizon without end. Scattered across it are islands of light, galaxies, each one a floating world of billions of suns, sailing slowly through the dark. Like lanterns upon a cosmic tide, some spin in graceful spirals, some glow in soft ovals of ancient stars, others burn with the energy of newborn suns, and all are bound together by an invisible thread, gravity, the silent composer of the universe. How many galaxies fill the night? How far does their light travel to reach your eyes? And what do they whisper about the story of time? In this quiet voyage, we'll wander through 101 sleepy facts about galaxies, their births, their collisions, their mysteries, and their destinies. So find a comfortable place. Let the darkness outside blend with the calm within. And as we begin, let each fact be a gentle ripple. In the endless ocean of light, the young universe and the first light. In the beginning, the universe was not filled with stars or light, but with silence, a dense, glowing fog of particles cooling after the Big Bang. Time itself was still learning how to flow. For hundreds of thousands of years, light could not travel freely. It was trapped, scattered endlessly by the hot soup of electrons and protons. But as the universe expanded and cooled, these particles began to combine into the first neutral atoms, mostly hydrogen and helium. The fog slowly cleared, and the first light escaped. This was the moment of cosmic dawn, when darkness met its first boundary. That ancient light, still traveling through space today, is what we call the cosmic microwave background, a faint whisper. From when the universe was only 380,000 years old. Every direction we look, it gently reminds us. Everything that exists began from one shared glow, hydrogen, the seed of all stars. Almost everything that exists in the universe began with hydrogen. It is the simplest element, one proton, one electron. Yet it is the foundation for all the complexity to come. In the early universe, immense clouds of hydrogen drifted through the dark, drawn together by gravity. Slowly, the clouds thickened, their centers heating under pressure. When the temperature rose high enough, millions of degrees, hydrogen atoms fused into helium, releasing light for the first time from within matter. That was the birth of the first stars. Every sparkle in the sky today is a descendant of that. Ancient chemistry, a continuation of that first fusion flame. In a sense, hydrogen is memory, the purest form of potential, waiting patiently in the dark until the universe was ready to shine. Gathering stars, the birth of proto-galaxies. As the first stars ignited, their light illuminated the vast cosmic fog. But stars did not form alone. Gravity, always the patient sculptor, began to draw them together. Small groups of stars merged into larger clusters, and those clusters merged again, forming the earliest galactic seeds, proto-galaxies. These were not the grand spiral structures we see today, but irregular gatherings of gas, dust, and newborn stars. Within them, turbulence reigned. Some regions collapsed under their own weight, forming dense cores. Others were blown apart by supernova explosions. Yet from this chaos, balance emerged. The gravitational dance of countless suns set the stage for structure. Over time, these clumps would merge, collide, and evolve into the galaxies that now fill our night sky. From darkness to light, the era of reionization. After the first stars formed, their radiation began to transform the universe once again. The ultraviolet light they emitted was powerful enough to strip electrons from nearby hydrogen atoms, turning the neutral gas back into an ionized plasma. This marked the era of reionization. When the darkness of the cosmic night began to fade, light spread like a rising tide, pushing back the shadows between galaxies. This process took hundreds of millions of years, slowly clearing the cosmic fog that once filled space. By the end of this era, the universe had become transparent, a place where light could travel freely. The sky, once opaque, opened up. Every photon from that time still moves outward today, carrying the memory of the universe's first sunrise. The invisible hand, dark matter, shapes the cosmos. While stars and gas made the universe visible, it was something unseen that shaped it. Dark matter, a mysterious substance that neither emits nor absorbs light, formed a vast invisible framework in space. Its gravity pulled ordinary matter toward it, forming halos where galaxies would eventually grow. Without dark matter, the gas of the early universe would have remained too evenly spread, unable to form the dense knots needed to ignite stars. In a way, every galaxy is a visible echo of an invisible skeleton. Even now, long after their birth, galaxies remain wrapped within dark matter halos, their shapes and motions still guided by this unseen force, the silent architecture of creation. Gravitational collapse, the formation of galactic halos. As dark matter halos grew, their gravity became irresistible. Clouds of gas began to fall inward, collapsing under their own weight. With each collapse, pressure and heat built up until the gas could no longer fall freely. It began to spin. This spinning motion flattened the gas into a rotating structure, the earliest galactic halos. These halos were turbulent, glowing with bursts of new stars, surrounded by streams of dark matter. Within them, gravity and motion reached a delicate equilibrium. It was here, in these swirling cradles of light and shadow, that the universe began to sculpt the first true galaxies. Every spiral we see today still carries this ancient motion, the memory of its first spin. Small beginnings. The first galaxies were tiny. When the first galaxies appeared, they were small, mere sparks in an enormous void. Many were no larger than a single modern star cluster, containing only a few million stars. Yet even in their smallness, they were magnificent. Their light pierced a universe still wrapped in darkness. Their gravity began linking them into larger systems. Over time, mergers between these tiny galaxies built the massive spirals and ellipticals we know today. The Milky Way itself was once a collection of such fragments, slowly woven together over billions of years. From small beginnings came cosmic grandeur, the same way a single heartbeat leads to life. The first stars, titans of fire. The first generation of stars, called population 3 stars, were unlike any we see today. Born from pure hydrogen and helium, they lacked the heavier elements that cool gas clouds and slow star formation. As a result, they grew enormous, some hundreds of times more massive than our sun. They burned hotter, lived faster, and died young, often in titanic supernova explosions. These explosions were the first great chemical events in the universe, scattering newly forged elements into space. Carbon, oxygen, iron, the building blocks of planets and life, were born in their deaths. Though none of these stars remain, their legacy is written in every atom of our world. The first supernovae, seeding the cosmos. When the first massive stars ended their short, brilliant lives, they did so in explosions of unimaginable power. In seconds, they released more energy than our sun will emit in its entire lifetime. These first supernovae enriched the surrounding gas with heavy elements, transforming the chemistry of the cosmos. Before them, the universe contained only hydrogen and helium. After them, there were the seeds of everything else, the minerals that would someday form planets, oceans, and even the cells of living creatures. Each explosion was both an ending and a beginning, the death of a star and the birth of a richer universe. Galaxies arise, hundreds of millions of years after the Big Bang. Roughly 300 to 400 million years after the Big Bang, the first galaxies emerged from the cosmic dark. They were faint and small, yet powerful in their collective glow. Astronomers today, looking through the deepest fields of space, can still see the light from those times. That light has traveled for over 13 billion years to reach us, stretched by the expanding universe into the faint infrared. When we observe it, we are looking into the past, seeing the cosmos as it was when it first learned to organize itself into islands of light. Each of those galaxies is a time capsule holding the story of cosmic dawn. Hubble's deep vision, the ancient light revealed. In 2004, the Hubble Space Telescope stared into a small, empty patch of sky for more than 11 days. What it found changed our understanding forever. That image, the Hubble Ultra Deep Field, revealed nearly 10,000 galaxies, each one existing billions of years ago. What once seemed like emptiness was overflowing with light. Every point of color in that picture is an entire galaxy, filled with stars and worlds. The deeper Hubble looked, the further back in time it saw, toward the birth of structure itself. It reminded us that the universe is not empty, but infinitely abundant. James Webb and the Edge of the Beginning. Nearly 20 years later, the James Webb Space Telescope took humanity even closer to the beginning. With its powerful infrared eyes, Webb pierced the cosmic fog to reveal galaxies older and smaller than any seen before. Some formed only 200 million years after the Big Bang, mere moments after the first stars ignited. In its golden mirrors, we see not only ancient light, but also the reflection of our curiosity, stretched across 13.5 billion years of time. Each faint smudge Webb uncovers is a spark from the universe's earliest fire, still glowing across eternity. The oldest galaxies known. Among the galaxies discovered by Webb is one known as Glass Z13, believed to have formed just 320 million years after the Big Bang. Its light is more than 13.4 billion years old, one of the oldest signals ever detected. It is tiny, irregular, and faint, but its very existence reshapes what we thought possible. Galaxies began forming earlier, faster, and in greater numbers than our models predicted. The early universe was more efficient at building order than we once imagined, as if creation itself was in a hurry to begin the story of stars. Chaos in form. Early galaxies were wild. The first galaxies were not the elegant spirals or smooth ellipticals we know today. They were chaotic, uneven, often merging with one another. Their light flickered as new stars were born and others exploded. Clouds of gas collided, twisted, and streamed outward in vast tendrils. To look at them would be to see motion itself, a dance between creation and destruction. Yet from that chaos, order was slowly emerging. Each collision redistributed energy and material, smoothing the rough edges of the cosmic landscape. Gravity, the great sculptor. Across billions of years, gravity continued to refine the universe's rough sketches. Wherever matter gathered, it pulled in more. Galaxies began to spin, their shapes flattening into disks. The most stable survived, the most chaotic were absorbed. Gravity gave form to the formless, weaving a tapestry of stars that stretched across space. Every spiral arm, every cluster, every orbit is a signature of its silent artistry. Without gravity's patience, the universe would still be in unformed fog. It is the cosmic artist, painting with the invisible brush of attraction, collision, and growth. Galaxies learned to evolve. When galaxies collided, they did not shatter, they transformed. The merging of gas and stars triggered new waves of star formation, lighting up the universe anew. These collisions were common in the early cosmos. They built larger and more complex systems. Over time, small galaxies fused into grander ones. each merger leaving a faint scar of disrupted stars. A reminder that creation and destruction are often the same process viewed from different timescales. Even our Milky Way is the result of many such unions, ancient cosmic marriages written in starlight, cooling streams, building galactic disks. As galaxies grew, streams of cooler gas flowed inward from the surrounding space. These cooling flows fed the birth of stars and helped galaxies settle into rotating disks. The balance between heating and cooling determined their fate. Too hot, and gas escaped. Too cold, and it collapsed too quickly. Over billions of years, galaxies found equilibrium, forming the smooth, rotating systems we see today. Within those disks, spiral arms began to wind, and with them came rhythm, the slow breathing of cosmic creation. From chaos to structure, a universe takes shape. By 1 billion years after the Big Bang, the universe had transformed from a turbulent mist into a structured realm of galaxies, clusters, and filaments. The cosmic web, a vast network of matter, had begun to emerge. Each node of that web contained a galaxy, each strand connecting them through gravity. What was once random became organized. Light now traced patterns across the dark, revealing that the universe was not a void but a living geometry, ever expanding, ever forming. Galaxies, the fundamental cells of the universe. If the universe were a living organism, galaxies would be its cells. Each contains stars, gas, dust, and dark matter, working together in a delicate balance, exchanging energy and material with their surroundings. Just as cells build bodies, galaxies build the cosmic structure. They birth stars, forge elements, and recycle their matter through generations of light. Every atom in your body once belonged to one of these galactic cycles. You are, in a literal sense, made from their dust, a fragment of their long and luminous evolution. Every galaxy is a story. Every galaxy is more than a collection of stars. It is a story written in light. Its shape tells of collisions survived. Its color reveals the ages of its stars, and its motion whispers the presence of invisible matter. Some shine fiercely, others fade quietly into the background. Together, they form the autobiography of the cosmos, the record of how matter learned to organize itself, how darkness gave birth to beauty. When we look up at the night sky, we are reading the oldest stories ever told, stories still being written in the language of light and time. The 3 layers of a galaxy. Every galaxy, despite its size and variety, follows a quiet architecture of 3 main parts: the disk, the bulge, and the halo. The disk is the flat, rotating plane where most stars, gas, and dust reside, the region of spirals and ongoing creation. The bulge rises at the center, a crowded sphere of old stars that glows warmly in the dark. Beyond both, an invisible halo extends far into space, home to ancient clusters and the unseen pull of dark matter. These 3 layers, visible and hidden, are bound together by gravity, moving in silent coordination. To look at a galaxy is to see structure born from chaos, balance written in starlight. The disk, home of spirals and young stars. The galactic disk is a place of life and renewal. Here, vast lanes of gas and dust circle the center like rivers of creation. Within these rivers, pressure and gravity weave together to form new stars, young, hot, and blue, shining brilliantly against the darkness. The disk is thin compared to its width, often only 1,000 light-years thick, but stretching 100,000 across. It rotates gracefully, carrying billions of suns in a quiet rhythm that takes hundreds of millions of years to complete a single turn. In the spiral arms of this disk, the galaxy continues to breathe, inhaling gas, exhaling light. The bulge, a heart of ancient stars. At the core of many galaxies lies a bulge, a dense, glowing sphere of old stars. These stars are ancient, remnants of the galaxy's earliest times, burning with steady, reddish light. The bulge is calm, lacking the turbulence of the disk. Here, orbits are random. Stars move in every direction, like a swarm around a hidden center. The bulge often holds clues to a galaxy's past, how it formed, merged, and aged. Its soft glow, when viewed from afar, is the galaxy's heartbeat, constant, enduring, and filled with memory. The halo, the invisible embrace. Surrounding every galaxy is a vast halo, mostly invisible, extending far beyond what we can see. It is home to globular clusters, tight spheres of old stars orbiting like moons, and, more importantly, it contains the majority of the galaxy's dark matter. Though unseen, the halo's gravity binds everything together, keeping the disk from flying apart as it spins. It stretches for hundreds of thousands of light years, merging softly with intergalactic space. If the galaxy is an island of light, the halo is its invisible ocean, holding it in gentle equilibrium. The central black hole, the gravitational heart. At the very center of almost every large galaxy lies a supermassive black hole, millions or billions of times the mass of our sun. It is the dark heart of the galaxy, silent, yet powerful. Around it, stars orbit at astonishing speeds, and some are torn apart by its gravity. When gas falls inward, it heats up and emits brilliant radiation, briefly turning the galactic core into one of the brightest objects in the universe. In our Milky Way, that heart is called Sagittarius A*, a massive presence, quiet now, but capable of awakening in flashes of X-ray light. Like a hidden pulse, it anchors the galaxy's motion, unseen yet essential. Globular clusters, the ancient wanderers. Drifting through the galactic halo are hundreds of globular clusters, each containing hundreds of thousands of stars packed tightly together. These stars are among the oldest in existence, fossils from the early days of the universe. They orbit the galaxies, core in long, slow paths that take billions of years to complete. To gaze at one is to look back through cosmic history, into a time when galaxies were still forming. Their light is faint and golden, like the glow of forgotten fires, still burning softly against eternity. The spiral arms, conveyors of creation. The spiral arms of a galaxy are not solid structures, but patterns of density, waves of compression that move through the disk. As these waves pass, they squeeze clouds of gas, triggering new star formation. Young, hot stars illuminate the arms, tracing their curves like luminous paint on a cosmic canvas. As the stars age and drift away, new ones form behind them, keeping the pattern alive. The spiral arms are like conveyor belts of creation, moving matter, recycling energy, sustaining beauty over billions of years. Cosmic dust, the veil of life. The dark lanes that streak across galaxies are made of cosmic dust, fine particles of carbon, silicon, and ice. Though it dims and scatters light, this dust is essential for creation. It shields newborn stars from harsh radiation, helps gas cool and collapse, and provides the raw material for planets. What looks like shadow is in fact the nursery of light. In every galaxy, dust both conceals and nurtures, reminding us that obscurity is often the beginning of birth. Hydrogen, the galaxy's breath. If galaxies could breathe, their air would be hydrogen gas. It fills their disks and halos, invisible to the eye, but glowing faintly in radio wavelengths. This hydrogen is the raw material from which stars are made. Over time, gravity gathers it into clouds, and when those clouds grow dense enough, fusion begins. Starlight is born anew. When stars die, they return hydrogen and heavier elements to the gas, continuing the cycle. The galaxy, in this way, inhales and exhales over cosmic timescales, a slow, rhythmic act of renewal. The spiral pattern, waves of density and time. The elegant spirals that define galaxies are not static. They are density waves, patterns that move slower than the stars themselves. As stars and gas orbit the center, they pass through these waves, compressing and decompressing like traffic along a cosmic highway. This compression triggers star formation, lighting the arms temporarily before the pattern moves on. It is a self-sustaining rhythm, structure emerging from motion. Even after billions of years, the spirals persist, their shapes maintained not by solidity, but by harmony. Order in motion, perfect orbits of chaos. In the galactic disk, billions of stars orbit the center in nearly perfect paths. Yet no two stars move exactly the same way. Their combined gravity creates a dynamic equilibrium, a balance that looks like chaos, but holds astonishing stability. It's like watching waves in an endless ocean. Individual ripples change, but the sea remains. Each orbit contributes to the galaxy's overall harmony. Together, they form a rotating sculpture of motion, light, and time, a masterpiece of natural engineering. HI regions, the glowing cradles of stars. Within the spiral arms lie regions of intense light, HI. Regions, where young, massive stars ionize the surrounding gas. The hydrogen there glows in shades of pink and red, signaling the birth of new suns. These are stellar nurseries, vast and luminous, scattered across the disk like jewels. Each one may contain thousands of newborn stars, still surrounded by the dust that gave them life. To peer into an HI region is to see the process of creation happening now, a living continuation of the universe's first fires. A symphony of light, billions of stars as one. The glow of a galaxy comes not from one source, but from the sum of billions. Each star contributes a single note. Together they form a silent symphony of light. From afar, their collective radiance merges into a smooth, glowing disk. Some stars are blue, others gold. Some nearly invisible, yet all blend into a single tone. Through telescopes, that glow reveals the galaxy's soul, bright where life is new, dim where it has aged. When you see a galaxy in the sky, you are witnessing a community of suns singing together in silence. Mass and motion, the rule of rotation. How fast a galaxy spins depends on how its mass is distributed. Near the center, stars orbit faster due to stronger gravity. But in the outer regions, something strange occurs. Stars continue to move at nearly the same speed instead of slowing down. This discovery puzzled astronomers and led to one of the great revelations of modern science. Most of a galaxy's mass is invisible. What we see, the stars and gas, accounts for only a fraction. The rest is dark matter, the unseen glue holding everything together. The hidden truth in galactic rotation. The fact that galaxies don't rotate like solid disks, that their outer stars move faster than expected, is the evidence for dark matter's existence. Without this hidden mass, the galaxies would simply tear themselves apart. Instead, they remain whole, spinning gracefully through the ages. In this way, dark matter reveals itself not through light, but through motion. The invisible is known by the visible survival, a quiet truth that echoes through the entire universe. The warm heart, red light of ancient stars. Look toward the center of a galaxy, and you'll see a warm, reddish glow. That color comes from ancient stars, cooler and older than their blue, youthful cousins. They burn gently, their energy steady, their lives long. The red light is like the fading embers of a cosmic fire, a sign of maturity and endurance. In that calm light lies the memory of billions of years, the echo of the galaxy's earliest days, still softly shining through the dust. The blue rim, youth in the outer arms. At the outer edges of galaxies, the light shifts to blue. These are the young stars, hot, bright, and short-lived. They are the children of the spiral arms, born from dense clouds of hydrogen. Their brilliance outshines everything around them, but only for a brief cosmic moment before they fade or explode. Their color is a symbol of energy and renewal. Together, the red core and blue rim create a natural gradient, the galaxy's heartbeat. Made visible from calm center to radiant edge, the enduring spiral patterns across time. Despite billions of years of change, spiral galaxies maintain their graceful shapes. Collisions, starbirths, and gas flows may disturb them, but the spiral pattern reforms again and again. The density waves and gravitational balance preserve this design, as if the universe has chosen to repeat beauty indefinitely. Each arm tells the story of constant renewal, of stars born, shining, and fading, while the structure endures. It is a lesson in patience, motion without chaos, evolution without loss, harmony of forces, gravity and energy in balance. A galaxy survives through balance. Gravity pulls inward, trying to collapse the system. Motion pushes outward, seeking freedom. Reason galaxies can spin for billions of years without falling apart. In this equilibrium, we see nature's quiet intelligence, order born not from control, but from relationship. A living ecosystem of physics and light. A galaxy is not a static object. It is a living ecosystem of matter, energy, and time. Gas becomes stars, stars forge elements, supernovae spread them, and gravity gathers them. Once again, the process repeats endlessly, death feeding birth, chaos feeding order. The galaxy grows, evolves, and interacts with others, like cells in a vast cosmic organism. To understand a galaxy is to understand that creation is continuous. Every photon that leaves its stars carries this message. Nothing in the universe stands still. Everything shines by becoming. Hubble's vision. The three main types. In the 1920s, astronomer Edwin Hubble looked into the deep sky and began to classify the shapes of galaxies. What he found was astonishing in its simplicity and beauty. He arranged them into three main categories: spiral, elliptical, and irregular. His Hubble tuning fork diagram became the universal language of galactic forms. Each shape, he realized, was more than geometry. It was history written in light. The spirals were dynamic and full of youth, the ellipticals serene and ancient, and the irregulars chaotic, reminders that the universe itself is both orderly and wild. Spiral galaxies, grace in motion. Spiral galaxies are perhaps the most iconic, vast disks of stars curving outward in luminous arms. Their form is elegant, like whirlpools of starlight frozen in time. The Milky Way is one of them, its spiral arms rotating slowly, carrying billions of suns along their paths. Within these arms, gas and dust form new stars, while older ones shine from the calmer regions between. The spiral pattern reflects balance, a dance between gravity, rotation, and time. If you could watch one for millions of years, you'd see it breathe. New stars born at the edges, old ones fading at the core. Elliptical galaxies, the ancient giants. Elliptical galaxies are immense, rounded structures, vast clouds of ancient stars without clear features or spiral arms. They shine in shades of gold and red, their light calm and uniform. Unlike spirals, they contain little gas or dust, meaning new stars rarely form. These galaxies are old, often the result of collisions and mergers that smoothed out their original shapes. Some are small and faint. Others, like M87 in Virgo, are giants containing trillions of stars. In them, we see the quiet maturity of the cosmos, structure simplified by time, glowing softly in eternal rest. Irregular galaxies, the wild ones. Not all galaxies follow order. Some are irregular, lacking clear shape or symmetry. They twist, stretch, and fragment like strokes of paint flung across the canvas of the universe. These forms often arise from gravitational encounters, galaxies torn or distorted by nearby giants. Yet within this apparent chaos, creation continues. New stars flare, gas clouds shimmer, and dust flows in luminous streams. Appearance, it is memory. Spirals tell of calm evolution, where gas could settle and spin. Ellipticals speak of violent pasts, collisions and mergers that erase their structure. Irregulars carry the scars of gravitational tides. Each shape is a record of what has happened and what still lingers, the forces felt, the stars born, the battles survived. To study form is to read history, written not in ink, but in the geometry of light. Spirals and abundance, rich in gas and dust. Spiral galaxies are the fertile gardens of the cosmos. Their graceful arms are rich in gas and dust, the raw ingredients for star formation. Here, hydrogen clouds drift between lanes of starlight, condensing into clusters of glowing blue suns. Dust weaves through them like veins, dark yet full of life. This constant cycle of creation and renewal gives spirals their vivid color and complexity. They are the cosmic equivalent of springtime, ever in motion, ever alive. Ellipticals, the children of collisions. In contrast, elliptical galaxies are the quiet aftermath of cosmic violence. When two spirals collide, their gas clouds smash together, triggering a burst of star formation. Eventually, the gas is used up or blown away, leaving only a smooth, rounded halo of aging stars. The once-ordered rotation of disks becomes random motion, and the spiral arms dissolve into uniform light. These galaxies are like ancient ruins, beautiful in stillness, sculpted by chaos long past. Irregulars, fragments of gravitational encounters. Many irregular galaxies exist as fragments, the torn remains of once stable systems. When larger galaxies pass nearby, their gravity pulls on smaller companions, stretching them into bizarre shapes. Streams of stars may trail behind, like comet tails hundreds of thousands of light years long. Yet even in their distortion, these galaxies shine defiantly, still forming stars, still radiating light. They are the survivors of the universe's endless tides. Dwarf galaxies, the hidden majority. Though we often marvel at grand spirals, the universe is mostly filled with dwarf galaxies, small, faint, and often overlooked. They can contain as few as a few million stars, compared to hundreds of billions in giants like the Milky Way. Some orbit larger galaxies like satellites, others drift freely through intergalactic space. Despite their size, they are vital. Dwarfs are the building blocks from which bigger galaxies formed through mergers over time. They are the quiet architects of the cosmos, hidden yet essential. Swarms of companions. Around every great galaxy swarm dozens, even hundreds, of smaller ones. The Milky Way alone hosts more than 50 known satellites. Some, like the large and small Magellanic Clouds, are visible even to the naked eye in the southern hemisphere. Others are faint and ghost-like, detectable only through deep surveys. These companions orbit their host galaxies like moons, pulled by gravity, shaped by tides, and slowly, over billions of years, merging with the greater whole. The cosmic hierarchy repeats itself, from atoms to stars to galaxies, each bound to something larger. The Magellanic Clouds, neighbors in motion. The large and small Magellanic Clouds are two dwarf irregular galaxies dancing around the Milky Way. They are connected by streams of gas and stars, evidence of their mutual gravitational pull. In their glowing regions, New stars are forming even now. To the human eye, they appear as pale smudges in the southern sky, yet they are entire worlds of their own, each spanning tens of thousands of light years. Their orbit around our galaxy is both a waltz and a slow embrace, destined to merge in the distant future. Tidal disruption, the cosmic pull. When a smaller galaxy ventures too close to a larger one, tidal forces stretch and distort it. Its stars are drawn into long, luminous streams, curving through space like ribbons of light. Over time, the smaller galaxy may be completely absorbed, its material scattered into the halo of the larger. The Milky Way itself is doing this now, tearing apart nearby dwarfs and weaving their remnants into its structure. Through this slow process, galaxies feed and grow, recycling each other's stars into new arrangements of light. Stellar tails, trails across the night. Some galaxies bear dramatic tidal tails, streams of stars and gas that stretch hundreds of thousands of light years into the void. These tails are the signatures of past encounters, cosmic scars left by gravitational battles. The antennae galaxies, for example, display two long arcs of stars curving outward like insect limbs. They are among the most beautiful sights in astronomy, proof that even in collision, the universe creates art. Each trail is a frozen echo of motion, a reminder that even destruction can produce grace. Lenticular galaxies, the in-between kind. Between spirals and ellipticals lies a hybrid, the lenticular galaxy. These systems have the smooth central bulge of ellipticals and the flat disk of spirals, but no visible arms. They are often galaxies that have exhausted their gas, ending star formation but retaining their shape. Lenticulars represent a transitional stage, once lively spirals, now quieted by time or stripped by environment. Their appearance is serene, like galaxies caught between youth and old age, still spinning, but in silence. Barred spirals, the galaxies with a cross of light. Roughly 2/3 of all spiral galaxies feature a bar, a bright, elongated structure of stars cutting across the center. The Milky Way is one of them. This bar acts like a gravitational channel, funneling gas toward the core, feeding both new stars and the central black hole. The bar's existence hints at a galaxy's maturity. Over time, rotation and density waves naturally produce it. Seen from afar, the bar adds symmetry and strength, a bright cross within a swirling disk of motion. Seyfert galaxies, the glowing hearts. Some galaxies shine with a mysterious brilliance at their centers. These are Seyfert galaxies, named after astronomer Carl Seyfert, who first described them in 1943. Their cores emit strong radiation, powered by material spiraling into a supermassive black hole. Though they look like ordinary spirals from the outside, their hearts blaze with ultraviolet and X-ray energy. They are the quieter cousins of quasars, galaxies where the nucleus has awakened, reminding us that even the calmest systems hold hidden fire within. Starburst galaxies, the explosions of creation. Occasionally, a galaxy experiences a starburst, a brief but intense period of star formation, triggered by collisions or gravitational shocks. These bursts can create thousands of new stars each year. The energy released floods the surrounding space with light, wind, and radiation. Yet such activity is unsustainable. Within a few 100 million years, the gas is used up or blown away, and the galaxy falls into calm again. Starburst galaxies are cosmic fireworks. Bright, short-lived, and unforgettable. Dwarf spheroidals, the silent ancients. Dwarf spheroidal galaxies are among the faintest and oldest known. They have little gas, no spiral arms, and contain mostly old, dim stars. Many orbit larger galaxies as companions, slowly eroding under tidal forces. Though they lack glamour, They hold priceless clues to cosmic history. Their stars preserve the chemical record of the early universe, untouched for billions of years. In their quiet light, astronomers read the story of the first generations of stars, the earliest chapters of galactic evolution. Ultra-diffuse galaxies, shadows made of stars. A strange class of galaxies, called ultra-diffuse galaxies, defy expectation. They are as large as the Milky Way but contain only a fraction of its stars. Their light is ghostly, spread so thin that they nearly disappear into the background of space. Some seem to have almost no dark matter, others are dominated by it. They challenge our understanding of how galaxies form and survive. To find them, astronomers must look carefully, for these are galaxies that exist at the edge of visibility, like whispers in the cosmic dark. No two galaxies are alike. Across the observable universe, there are billions of galaxies, perhaps 2 trillion, yet no two are identical. Each carries its own proportions of stars, dust, and dark matter, its own scars of collisions and births. Some are grand and bright, others faint and fleeting. Together, they form a cosmic symphony of variation, endless expressions of the same laws of physics, endlessly rearranged. Like snowflakes, galaxies share a pattern, but never the same story. To look upon them is to glimpse infinity's imagination. The Milky Way, a barred spiral galaxy. Our home galaxy, the Milky Way, is a barred spiral, a vast disk of stars with a bright, elongated bar at its center. From the side, it looks like a thin, glowing blade of light. From above, a swirling flower of spiral arms. The bar acts like a bridge, channeling gas and stars toward the core. Within its graceful structure lie more than 200 billion suns, woven together in rotation. From Earth, we cannot see the Milky Way as a whole, but we can feel its shape in the band of stars that crosses the night sky, the soft river of our own home. 100,000 light-years across. The Milky Way stretches roughly 100,000 light-years from edge to edge, a scale so vast that even light, moving at 300,000 kilometers per second, would take 100 millennia to cross it. Inside this immense structure, stars orbit in wide spirals, clouds of gas drift slowly, and dark matter extends far beyond the visible rim. Every speck of light you see in the night sky, every familiar constellation, lies within this disk. We live not at its center, but far out on one of its arms, moving quietly with everything else in its orbit. 200 billion suns and counting. Astronomers estimate that the Milky Way contains 200 to 400 billion stars, perhaps even more. Some are ancient red dwarfs, burning steadily for trillions of years. Others are young blue giants, shining brightly before fading. Many stars have planets, likely billions of them, and among those worlds, some may host oceans, clouds, and life. The number is overwhelming, but it reminds us of something gentle. We are not alone in the dark. We are one of countless lights in a galaxy of unending variety. The sun's modest address. Our sun sits about 27,000 light-years from the galactic center, halfway between the core and the outer rim. It orbits the galaxy at a speed of 220 kilometers per second, completing one revolution roughly every 225 million years. That means since the dinosaurs walked the Earth, our solar system has made only one full turn around the Milky Way. We live not in the crowded core nor the empty outskirts, but in a quiet, stable suburb of the galactic city, the perfect place for life to endure. The heart of darkness, Sagittarius A*. At the center of the Milky Way lies Sagittarius A*, a supermassive black hole with the mass of about 4 million suns. It sits hidden behind dense clouds of dust and gas, invisible to our eyes but detectable through radio waves and X-rays. Around it, Stars orbit at incredible speeds, whipped by its gravity into tight ellipses. Though silent now, Sagittarius A** once blazed brighter, feeding on infalling gas. It is the heart of our galaxy, dark, powerful, and ancient, anchoring everything in its invisible embrace. Stars that dance around the void. Close to the center, near Sagittarius A*, a cluster of stars moves with astonishing velocity, some reaching thousands of kilometers per second. Their orbits are so tight and fast that they allowed astronomers to prove the black hole's existence beyond doubt. These stars, like sparks swirling around a drain, map the gravitational shape of the galaxy's heart. Their motion reveals a paradox. Even where light cannot escape, its pull can be traced by the dance of those who orbit close to the abyss. A family of satellites. The Milky Way is not alone. It is surrounded by a family of smaller galaxies, at least 50 known companions. Some are bright and distinct, others are ghostly, barely visible. These satellite galaxies orbit slowly in the dark halo, held by gravity, yet slowly drifting inward over cosmic time. Together, they form a complex gravitational ecosystem, a community of worlds connected by invisible threads of motion. In their quiet orbits, they tell the story of how great galaxies grow by gathering the small. The Magellanic Clouds, our close neighbors. Among the Milky Way's companions, the large and small Magellanic Clouds are the most striking. Visible to the naked eye from the southern hemisphere, they appear as soft, cloud-like patches near the Milky Way's glow. These are dwarf irregular galaxies, rich in gas and dust, still forming new stars. They dance together as they orbit our galaxy, connected by a stream of hydrogen known as the Magellanic Bridge. In their luminous chaos, we glimpse the living interaction between galaxies, neighbors in eternal motion. The galactic feast, consuming the small. Over billions of years, the Milky Way has absorbed many smaller galaxies. Its halo is threaded with the remnants of these encounters, long streams of stars stretching across the sky, the remnants of devoured companions. This process is ongoing. Even now, our galaxy is pulling apart the Sagittarius dwarf galaxy, drawing it slowly into its structure. Such mergers are not acts of violence, but of transformation. Each adds new stars, new gas, new stories. The galaxy continually remaking itself from what it consumes. Stellar streams, the trails of gravity. All across the Milky Way's outer regions, stellar streams flow, faint rivers of stars, stretching for thousands of light years. They are the fossil remains of galaxies and clusters long since torn apart by gravity. Each stream traces the invisible curvature of the galactic halo, marking where something once was whole. For astronomers, these streams are like ancient handwriting, recording the long history of our galaxy's growth. For the imagination, they are ghost trails, the lingering paths of cosmic migration. The Orion Arm, our place in the spiral. Our solar system lies in a small spur of the Milky Way known as the Orion Arm, a minor branch between two of the galaxy's main spirals, Sagittarius and Perseus. This region contains many of the constellations and nebulae familiar to us, Orion, Cygnus, and the Pleiades. Cluster. It is our neighborhood in the grand disk, calm, moderate, and filled with stars of many ages. When we look up and see the Milky Way stretching across the sky, we are gazing along the plane of this arm, our home lane in the galactic highway. One galactic year, the sun's long orbit. The sun takes about 225 million years to complete one full orbit around the Milky Way, a journey called a galactic year. Since its birth 4.6 billion years ago, the sun has circled the galaxy roughly 20 times. During that time, continents have drifted, species have risen and fallen, and civilizations have just begun to dream of the stars. Yet the sun's motion never stops. It continues its slow, steady path through the disk, carrying Earth and all its stories with it, like a leaf in a boundless river. The night sky, a slice of our galaxy. When you look at the Milky Way on a clear night, you are not seeing another galaxy. You are looking from within our own. That glowing band is the dense plane of the galactic disk, seen edge on from our position inside it. Billions of distant stars overlap, their light blending into a continuous shimmer. The darker patches between them are lanes of dust that block the starlight. What appears to be a narrow stripe across the sky is actually a cross-section through a city of stars, the view from one window of our cosmic home. The hidden core, veiled in dust. The central region of the Milky Way, the bulge, is invisible to the naked eye. Thick clouds of dust obscure it completely, invisible light. Yet behind that veil lies a crowded realm of millions of stars, orbiting the black hole at the center. For centuries, this region was a mystery, hidden by its own creation. Only with modern instruments, radio and infrared telescopes, have we begun to lift the veil and see what lies beneath. A heart both luminous and dark, where creation and gravity meet. Seeing through dust, radio and infrared vision. To see beyond the dust. Astronomers turn to radio and infrared light. These wavelengths can pass through the dense clouds that block visible light. In infrared, the galactic center glows brightly, revealing clusters of stars and arcs of gas swirling around Sagittarius A star. Radio observations show jets and filaments of energy, tracing magnetic fields and particle flows. Together, these tools allow us to see our galaxy in its true form, a glowing, dynamic organism, alive in many colors beyond human sight. Gamma rays from the heart. The Milky Way's core emits powerful gamma rays, the most energetic form of light. These rays likely come from cosmic interactions, supernova remnants, pulsars, and perhaps activity near the central black hole. Detected by space observatories like Fermi, the gamma-ray glow reveals that our galaxy's center is not silent, but full of high-energy phenomena. Even in apparent stillness, the Milky Way hums with invisible light, the background heartbeat of creation continuing. At its core, ultraviolet light from young stars. In the spiral arms, young, hot stars flood space with ultraviolet radiation. Though invisible to our eyes, this light shapes the galaxy's chemistry. Ionizing gas, triggering new star formation, and carving glowing regions of color. In the ultraviolet view, the Milky Way appears as a ring of fire, blue and radiant, full of energy. These youthful stars are short-lived but essential. They renew the galaxy's brilliance, ensuring that each generation of stars inherits a universe still alive with light. The Milky Way on the move. Our galaxy is not stationary. It travels through the cosmos at about 600 kilometers per second, pulled by the gravity of nearby galaxies and clusters. Its most prominent neighbor, Andromeda, is moving toward us at roughly 110 kilometers per second. Though we are separated by 2.5 million light-years, the pull between us is unrelenting. The Milky Way and Andromeda are destined to meet, a slow-motion dance that will reshape both over billions of years. A future embrace with Andromeda. In about 4 billion years, the Milky Way and Andromeda galaxy will collide. Their stars will not crash, but their gravities will intertwine, pulling gas and dust into long streams, igniting waves of new star formation. Over time, their spiral structures will merge into one vast elliptical galaxy, sometimes called Milkomeda. The night sky then will be transformed, a luminous swirl filling the heavens, the result of two galaxies uniting in a silent cosmic waltz. The sky of tomorrow, brighter than ever. When that merger comes, the night sky will blaze with brilliance. Andromeda's stars will stretch across the horizon, our sun will see the heavens filled with spirals of light. It will be the most magnificent sky the Earth has ever known, though by then, life here may have long evolved or moved beyond. Yet even if no eyes remain to see it, the beauty will still unfold. For in the universe, spectacle is not made for witnesses. It is simply the natural expression of creation. The Milky Way will change, but its light will live on, reshaped, renewed, and still singing among the stars. Galaxies are always moving. Galaxies are not fixed in space. They drift, orbit, and fall toward one another under the pull of gravity. Every galaxy you see, every spiral, every cluster, is moving through the cosmic web at hundreds of kilometers per second. Even our own Milky Way sails through the local group, drawn slowly toward Andromeda. Over billions of years, these motions shaped the large-scale structure of the universe. The night sky seems still, but on the scale of eternity, galaxies flow like currents in an invisible ocean, always in motion, never truly still. When gravity begins to dance. When two galaxies come close, gravity awakens. Their halos of dark matter feel each other first, long before their stars align. The galaxies begin to stretch and curve, like dancers responding to a distant rhythm. Stars are pulled into streams. Gas clouds are compressed. Orbits distort. From a distance, the two galaxies appear to embrace, spiraling together in a slow and silent waltz. What begins as attraction becomes choreography, a gravitational ballet that can last for billions of years. Starbirth from collision. As galaxies interact, their gas clouds crash and compress, igniting bursts of star formation. These starbursts can light up entire regions of space, producing thousands of new stars each year. The shock waves of the encounter turn chaos into creation. From what seems like destruction, the universe writes new constellations. In the wake of each collision, there is renewal, bright, brief, and magnificent, proof that even the most violent forces can give rise to beauty. Bridges and tails of light. During these encounters, tidal forces pull streams of stars outward, forming long glowing tails and delicate bridges between galaxies. These luminous structures can stretch for hundreds of thousands of light years, connecting one galaxy to another like threads of silk. Over time, some of these stars fall back, others drift away into intergalactic space. To the human eye, such scenes look like art, vast strokes of light drawn by the invisible brush of gravity. When galaxies collide, stars rarely do. Even when galaxies appear to collide, the stars within them almost never physically touch. The distances between stars are so immense that they pass through one another harmlessly, like grains of sand scattered in a desert wind. What does collide are the clouds of gas and dust, which interact dramatically, heating, shocking, and forming new stars. The true collision happens not in matter, but in gravity and light. The result is transformation without destruction. The chaos of gas and dust. In galactic collisions, gas and dust play the leading role. Unlike stars, they are diffuse and easily disturbed. When two galaxies pass through each other, their interstellar clouds crash head-on, generating heat, turbulence, and magnetic storms. These chaotic encounters trigger starburst regions, fiery nurseries where light blooms in every wavelength. It is as though the universe breathes faster for a while, burning bright before settling once again into calm. The antennae galaxies, beauty in collision. One of the most iconic examples of a galactic merger is the antennae galaxies, located about 45 million light-years away. Two spirals have met and are slowly merging, their arms twisted into long, antenna-like streams of stars. In their overlapping cores, thousands of new stars are being born. The collision began hundreds of millions of years ago and will continue for hundreds of millions more. When you look at the antennae, you are seeing the universe mid-creation, destruction, and birth woven into a single cosmic tapestry, the birth of elliptical giants. When galaxies finally merge, the result is often an elliptical galaxy, smooth, round, and filled with old stars. The chaotic mixing of orbits erases the delicate spirals, leaving behind a more uniform shape. Gas and dust are consumed or expelled, and star formation slows to a whisper. The young, blue glow fades into warm gold. From collision comes maturity, from motion, rest. Elliptical galaxies are the ancient monuments of these cosmic unions, quiet after centuries of dance. The perfect ring, the cartwheel galaxy. Sometimes, when a smaller galaxy passes directly through the heart of a larger one, it triggers a ring galaxy, a perfect, expanding circle of light. The most famous is the Cartwheel Galaxy, 500 million. It is the universe's version of a stone cast into water, except the pond is made of stars. Galactic mergers are common. Though they unfold slowly, galactic mergers are not rare. In fact, they are one of the main engines of galactic evolution. Every large galaxy has grown by consuming smaller ones, and sometimes by merging with equals. The universe may seem peaceful from afar, but beneath that stillness lies constant motion, constant transformation. Even now, countless galaxies across the cosmos are converging, their fates sealed by gravity's pull. Creation, it seems, has always been a social act. The Milky Way's past mergers. Our own Milky Way is no stranger to these encounters. Over its long history, it has merged with at least 10 smaller galaxies. Their remnants now part of our halo and disk. Streams of stars, such as the Sagittarius stream, are relics of these mergers. In a sense, we are made from the ghosts of other galaxies, absorbed, reshaped, and reborn within the spiral of our own. Even now, the Milky Way continues this process, quietly feeding, slowly evolving, preparing for its great meeting with Andromeda. Tidal tails, stretching for millions of light years. The tidal tails created by galaxy collisions can reach extraordinary lengths, sometimes extending millions of light years into space. These streams consist of billions of stars, pulled outward like cosmic ribbons. Some tails later condense into new dwarf galaxies, while others drift apart and vanish into the void. Each tail is a signature, a luminous fingerprint marking where two galaxies once met. The night sky is filled with these faint, forgotten trails, light that remembers motion. Galaxies being torn apart, not all interactions. And in merger, some smaller galaxies are slowly shredded by larger ones, stripped of stars and gas by tidal forces. The Sagittarius dwarf galaxy is one such victim, currently being torn apart by the Milky Way, its stars stretched into a stream that wraps around our sky. It is a gentle but inevitable process. Gravity shows no malice. It simply follows its nature, rearranging what exists into new forms of order. Mergers shape the modern universe. Much of the structure we see today, the size, color, and distribution of galaxies, is the result of billions of years of mergers and interactions. These events transformed small, irregular galaxies into the grand spirals and massive ellipticals that now populate the cosmos. Even the largest clusters of galaxies owe their form to this process. The universe, through countless slow collisions, has sculpted itself, building complexity out of motion, unity out of countless parts. Black holes also merge. When two galaxies merge, their supermassive black holes at the centers also begin to spiral toward each other. Over millions of years, they draw closer, orbiting faster and faster until they finally coalesce into one. The energy released is enormous, so intense that it sends ripples through the very fabric of space-time itself. These are the gravitational waves now detected by observatories on Earth. Each wave we record is a whisper from such an ancient union, a faint echo of gravity's final chord. The soundless symphony of gravity waves. When those black holes merge, the collision doesn't produce sound, but if it did, it would ring across the universe like a deep, cosmic bell. Instead, the energy travels as gravitational waves, stretching and squeezing space as they move. These waves pass through everything, including us, though we never feel them. Instruments like LIGO and Virgo can detect their tiny disturbances, distortions smaller than a proton, and from them, reconstruct the story of galaxies colliding billions of years ago. It is the music of the universe, inaudible yet real. Galactic encounters drive evolution. Without interactions, the universe would be static, each galaxy living alone, unchanged. But through encounters, galaxies evolve. They grow, exchange material, and trigger new star formation. Collisions redistribute angular momentum, spread heavy elements, and sometimes create entirely new structures. These interactions are the universe's way of learning itself, of experimenting with new arrangements of matter and light. Every meeting changes the participants forever, yet from each, something larger emerges. The universe rewrites itself. The cosmos is never finished. Every merger, every tidal pull, every stream of stars is part of an ongoing restructuring, a rewriting of the universe's design. The galaxies we see today are not what they once were, nor what they will become. Over billions of years, gravity reshapes everything. Stars, clusters, even the web of dark matter itself. Nothing is lost. Everything is rearranged. The universe, like a living mind, continuously edits its own story. Today's collisions, tomorrow's order. What appears chaotic now? Galaxies colliding, tails stretching, clusters merging, will, in time, settle into harmony. The turbulence of today becomes the structure of tomorrow. Each encounter smooths the cosmos, distributing mass and energy until balance is restored. From this perspective, even cosmic violence is part of a grand cycle. Disorder feeding order, creation emerging from collapse. Every collision is a step toward greater unity. Every encounter is a song of rebirth. When two galaxies meet, they do not simply end. They become something new. Their stars mix, their gas ignites. Their dark matter merges into a single halo. In time, the result is a galaxy richer, brighter, and more complex than before. It is rebirth through union. The universe, it seems, composes itself through such encounters, writing symphonies of gravity, harmony, and renewal. Every touch of light against light is both an ending and a beginning, a quiet hymn in the endless song of creation. Galaxies gather in groups. Galaxies, like stars, prefer company. Across the cosmos, they tend to cluster together under the pull of gravity, forming associations that drift collectively through space. Some contain just a few members, others hold thousands. These gatherings are the next level of cosmic architecture. Galaxies bound not by touch, but by mutual gravity, orbiting one another in vast, slow motion. The universe, even in its emptiness, is social by design. Every cluster is a community of light. The smallest family, a galaxy group. The smallest galactic gatherings are known as galaxy groups, collections of a few dozen galaxies bound by shared gravity. Within them, galaxies interact, merge, and exchange material over billions of years. Groups often include one or two dominant members surrounded by smaller companions. The average distance between galaxies in such a group may be only a few million light-years, close by cosmic standards. These groups are the neighborhoods of the universe, quiet clusters where the slow evolution of light continues. Our home group, the local group. The Milky Way resides within such a group, called the local group. It spans about 10 million light-years across and contains more than 50 galaxies, large and small. The Milky Way and Andromeda are the two giants, each surrounded by swarms of dwarf companions. Between them lies a delicate balance of motion, the faint gravitational pull that will one day bring them together. The local group drifts like a small island of galaxies, part of a far greater archipelago in the cosmic sea. 50 companions of light. Within the local group are over 50 known galaxies, including the Triangulum Galaxy, M33, the Magellanic Clouds, and dozens of faint dwarfs. Many are invisible to the naked eye, detectable only through their subtle glow in long exposures. They orbit, collide, and sometimes dissolve into each other. Our local group is modest compared to others, but it carries its own quiet beauty, a harmony of small and large, ancient and young, connected by gravity and shared history. Beyond groups, the great clusters. When galaxy groups bind together, they form clusters, enormous structures containing hundreds to thousands of galaxies. These clusters are the densest regions in the universe, where gravity reigns supreme. Within them, galaxies orbit one another like stars in a galactic-scale city, sometimes merging, sometimes drifting apart. Clusters are not static. They are dynamic ecosystems, alive with collisions, flows of hot gas, and the slow exchange of matter. To look upon one is to see a universe within. The universe. The Virgo cluster, our nearest giant. The Virgo cluster is the closest large cluster to us, about 54 million light-years away. It contains over 1,500 galaxies, from majestic spirals to massive ellipticals. The cluster's core is home to several enormous galaxies, including M87, which harbors a supermassive black hole so vast it can swallow our entire solar system many times over. The Virgo cluster's gravity subtly influences even us. The local group is slowly falling toward it, drawn by its colossal mass. It is the gravitational center of our cosmic neighborhood. Thousands of galaxies in one place. A large cluster can hold thousands of galaxies, each with hundreds of billions of stars. These galaxies are embedded in an even larger structure, a massive halo of dark matter that provides the gravitational glue. Between them flows a thin, superheated gas, glowing faintly in X-rays. If you could stand at the heart of such a cluster, the night sky would be filled with galaxies, hundreds visible at once, a landscape of light stretching in every direction. It would be both beautiful and overwhelming. Giants at the center. At the heart of many clusters lies a giant elliptical galaxy, sometimes called a central dominant galaxy. These titans are formed by countless mergers, consuming smaller galaxies that fall inward over time. They can span millions of light-years and contain trillions of stars. Their central black holes are among the largest in existence. Around them, the cluster's gravity wells deepen, drawing in matter and energy. In these centers, time seems to slow, a deep well of gravity surrounded by a halo of starlight. The scorching gas between galaxies. Between galaxies in a cluster lies a vast expanse of superheated gas, reaching temperatures of tens of millions of degrees. Though almost invisible in visible light, this gas emits powerful X-rays, revealing the true shape of the cluster. The gas is thin, a few particles per cubic meter, yet it outweighs all the stars combined. It is the atmosphere of the cluster, glowing faintly in the dark, holding the galaxies in its hot embrace. Clusters that shine in X-rays. Because of this hot gas, galaxy clusters are some of the brightest X-ray sources in the universe. Observatories like Chandra and XMM Newton have mapped their glowing halos, tracing where matter gathers and where dark matter hides. The X-rays also tell us the clusters are not static. They pulse, collide, and merge, heating the gas even more. In the silent void, they radiate an invisible brilliance, like embers burning in the vastness of space. The rise of superclusters. Clusters, too, are not the end of the hierarchy. They themselves group into even larger formations called superclusters, immense networks containing thousands of galaxies spread across hundreds of millions of light-years. Superclusters are the largest bound structures known, the continents of the cosmic landscape. They are not random. They form along filaments of dark matter, connected like beads on invisible strings. The universe, at its grandest scale, is a pattern of connection, a web, woven from gravity and time. Laniakea, our home supercluster. Our local group, along with the Virgo cluster and many others, belongs to the Laniakea supercluster, a structure stretching over 500 million light-years and containing about 100,000 galaxies. Its name, from Hawaiian, means immense heaven, a fitting description for the vast domain we inhabit. Laniakea is not a single object, but a flow, galaxies drifting together toward a common gravitational center. We are part of this great migration, moving not just within the Milky Way, but through an ocean of galaxies bound by shared motion, a network of thousands of groups. Within Laniakea are thousands of galaxy groups and clusters, each like a luminous cell in a cosmic organism. The Virgo cluster, the Hydra Centaurus cluster, and the Norma cluster are among its great hubs. Their combined gravity guides the motion of galaxies for hundreds of millions of light-years. These flows define the structure of the universe, not chaos, but subtle coordination, as if every galaxy knows, silently, which direction to move. The edge of Laniakea. The outer boundary of Laniakea is defined not by walls, but by motion, the point, where galaxies begin to drift toward other superclusters instead. Beyond it lies one of the great cosmic voids, vast regions almost entirely empty of galaxies. These voids are like the dark waters between islands, defining the shape of the cosmic web. To stand metaphorically at the edge of Laniakea is to look out across unimaginable emptiness and realize that even emptiness has form. The great attractor, the hidden center. Deep within Laniakea lies a mysterious region known as the Great Attractor, an unseen gravitational anomaly drawing galaxies, including ours, toward it. It's partially hidden behind the plane of the Milky Way, obscured by dust and stars. We cannot yet fully see what it is, perhaps a dense cluster or the heart of an even greater structure. But we can feel its pull, subtly steering the motion of entire galaxy groups. Even across hundreds of millions of light-years, gravity whispers. The cosmic web, a universe of threads. On the largest scales, galaxies are not scattered randomly. They form a cosmic web, a vast network of filaments, nodes, and voids. These filaments, made of dark matter and galaxies, stretch for hundreds of millions of light-years, intersecting at clusters and superclusters. Between them lie immense voids, almost completely empty. It is as if the universe itself were a woven fabric, luminous threads of matter stitched through darkness, connecting everything that exists. Filaments connecting superclusters. The filaments of the cosmic web are bridges between superclusters, channels along which matter flows. Gas streams along these filaments, feeding galaxies and clusters, sustaining star formation over billions of years. These threads are not static. They pulse with gravity and motion, slowly evolving as the universe expands. Through them, galaxies remain connected across unimaginable distances, like neurons sending silent signals across a universal mind. The vast voids. Between these filaments lie voids, regions spanning hundreds of millions of light-years with almost no galaxies at all. They are not empty, but they are close, thinly filled with dark matter, diffuse gas, and the faint glow of background radiation. These voids give the cosmic web its contrast, its rhythm, emptiness defining the luminous strands around it. To drift through one would be to travel through the deepest silence the universe can offer. The universe like a cosmic brain. When scientists map the large-scale structure of the universe, they notice something extraordinary. The pattern of galaxies and filaments resembles a neural network. Clusters act like nodes, filaments like connections. Both systems, the cosmos and the human brain, organize complexity through linked structures and flowing information. Perhaps it's coincidence, or perhaps it reveals a deeper symmetry in nature. The idea that awareness itself might be written into the architecture of existence. Each cluster a node of light. In this grand network, every cluster, every galaxy, is a node in a cosmic lattice, a point where gravity, matter, and light intersect. Together, they create the structure of the universe as we know it. Intricate, connected, alive with motion. To look across billions of light years is to see not chaos, but design, a pattern vast, beyond comprehension, yet governed by simple forces. The cosmic web is the universe's body, light is its voice, and we, small as we are part of its thought. The galaxies that shine too bright. Most galaxies glow softly, their light a blend of billions of calm stars. But a few stand out. Galaxies whose centers burn with astonishing brightness, often outshining the rest of their stars combined. These are active galaxies, their hearts alive with immense energy. The brilliance does not come from starlight, but from something deeper, stranger, the gravitational hunger of a black hole consuming matter at its core. In these galaxies, darkness itself becomes a source of light. When black holes begin to feed, at the heart of an active galaxy lies a supermassive black hole, millions or billions of times the mass of our sun. When gas, dust, or even stars drift too close, the black hole's gravity tears them apart. The material spirals inward, forming an accretion disk, a swirling, radiant whirlpool of plasma. Though nothing can escape the black hole once it crosses the event horizon, the friction and heat from infalling matter release tremendous energy just before it vanishes. It is this process, the feeding of the dark, that makes active galaxies shine like cosmic furnaces. Radiation from the edge of oblivion. As matter falls toward the black hole, it compresses and accelerates, heating to millions of degrees. This produces intense radiation, X-rays, gamma rays, ultraviolet light, and radio waves. Jets of charged particles are sometimes launched at near-light speed from the poles of the black hole, piercing the galaxy and extending into intergalactic space. All of this power comes not from nuclear fusion, but from gravity itself. The simplest force turned into the greatest engine of light. It is energy born at the edge of nothingness. The active galactic nucleus. Astronomers call these radiant hearts active galactic nuclei, or AGN. They are among the most energetic objects in existence. At their brightest, an AGN can release more energy in a second than our sun emits in 1,000,000 years. Surrounding them is a turbulent region of ionized gas, dust, and magnetic fields, a maelstrom that both feeds and hides the central black hole. From afar, the galaxy appears to have a shining core, a point of light so intense it can outshine the rest of its stars combined. The quasar, beacon of the early universe. Among all active galaxies, none are brighter than the quasars, short for quasi-stellar radio sources. First discovered in the 1960s, they looked like distant stars, but their light revealed immense redshifts, proof that they were billions of light years away. That meant they were brighter than Entire galaxies. Quasars are the blazing nuclei of young galaxies, powered by black holes devouring vast amounts of matter. They are the lighthouses of the early universe, shining across space and time to tell us where galaxies were being born. Light greater than a galaxy. A single quasar can emit more light than 1,000 galaxies combined. Its luminosity can exceed that of 1,000,000,000,000 suns. From Earth, we see them as faint pinpoints. Yet those tiny specks are energy storms billions of light years away. Their radiation spans the entire electromagnetic spectrum, from radio waves to gamma rays. And because they are so bright, we can see them even when the rest of the universe was still in its infancy. Their light reaching us from a time when galaxies were young and stars were just beginning to cluster, brighter than 1,000,000,000,000 suns. The most powerful quasars radiate energy equivalent to thousands of times the total output of the Milky Way. This light is produced by matter, spiraling into the black hole at nearly the speed of light. The gravitational energy released in that process, before the material crosses the event horizon, is converted into photons. The efficiency is astonishing. While nuclear fusion converts only 0.7% of mass into energy, accretion near a black hole can convert up to 40%. In the darkness of space, nothing is more efficient at creating light than a black hole that feeds the ancient brilliance of the early universe. Quasars were most common in the early universe, around 10 to 12 billion years ago. Back then, galaxies were young, rich in gas, and black holes were rapidly growing. Their hunger lit up the cosmos, turning the distant sky into a sea of fiery cores. Over time, as galaxies matured and their fuel ran out, quasars faded. Now, only a few remain active, mostly in the farthest reaches of the cosmos, echoes of a time when the universe was still learning to shine. Blazers, when the jet points at us. When one of a quasar's relativistic jets happens to aim directly toward Earth, we see it as a blazer, one of the most violent and variable objects in the universe. Its light flickers on timescales of days or even hours as particles near light speed blast radiation toward us. Blazers are not different from quasars. They are simply oriented in our direction, their brightness magnified. By perspective, in them, we see cosmic power aimed like a flashlight through the dark, a reminder that our view of the universe depends on where we stand. Radio galaxies, giants with hidden voices. Some active galaxies emit most of their energy as radio waves, earning the name radio galaxies. They possess enormous lobes of radio-emitting plasma stretching millions of light years from their cores. These lobes mark the paths of ancient jets, where particles accelerated by the black hole interacted with intergalactic gas. Even when their visible light fades, their radio glow endures, a whisper of past activity still echoing through space. It is the voice of a galaxy that once roared, jets reaching across millions of light years. The jets from active galaxies are among the most astonishing phenomena in the cosmos. They shoot out from the poles of the black hole's accretion disk, propelled by magnetic fields at nearly the speed of light. Some stretch for millions of light years, longer than the galaxies themselves. Within them, electrons spiral through magnetic lines, emitting synchrotron radiation, a cosmic signature of extreme motion. These jets can trigger new star formation, heat surrounding gas, and even sculpt the shapes of galaxies. They are gravity's way of drawing lines across the canvas of space. Signs of an active black hole. Astronomers identify active black holes by their fingerprints, bright X-rays, fast variability, radio jets, and emission lines from hot gas. Sometimes these signs are faint, hidden beneath dust. Other times, they blaze unmistakably across the spectrum. In every case, they tell the same story of matter falling inward, energy streaming outward, and gravity transformed into light. Through these clues, we can read the invisible, the secret life of galaxies whose hearts are awake. Energy from gravity. All the light of an active galaxy comes from one source, gravitational energy. As matter falls inward, it accelerates, releasing heat and radiation. No fusion, no chemical reaction, only motion under gravity's pull. This process is the most efficient energy conversion known in nature. It shows that even the simplest law, objects falling, can, under the right conditions, illuminate the universe. In this sense, every quasar is a reminder. Gravity does not only pull, it creates. When the fuel runs out, an active galaxy cannot shine forever. Eventually, the gas near its center is consumed or expelled by radiation pressure. Without fuel, the accretion disk fades, the jets stop, and the galaxy grows quiet. Its black hole remains, massive and invisible, waiting. If fresh material ever drifts close again, the process restarts. The dark heart reignites. For now, most galaxies are sleeping giants, their central engines dormant, their brilliance stored away like a memory of light. The Milky Way's ancient awakening. Even our own Milky Way once had an active past. Evidence in the form of Fermi bubbles, vast lobes of gamma-ray emission extending above and below the galactic plane, suggests that our central black hole, Sagittarius A*, was active a few million years ago. It may have once launched jets or outflows that lit up the galaxy's heart. Now it sleeps, quiet and faint, but its dormant power remains, waiting for the day when another cloud of gas will fall inward, and the Milky Way will blaze again. Quasars as cosmic yardsticks. Because quasars are so bright and distant, they serve as cosmic beacons, helping astronomers measure the expansion of the universe. By observing how their light is stretched, their redshift, we can calculate how fast space has expanded since their light began its journey. They also illuminate the gas and dust between galaxies, allowing us to study the cosmic web itself. Each quasar, therefore, is both a lamp and a ruler, showing us not just what exists, but how the universe grows. Lighthouses in the cosmic sea. Quasars are often called the lighthouses of the universe. They shine across billions of light years, guiding our understanding of cosmic history. Their beams cut through darkness that has lasted for eons, revealing how the first galaxies formed, evolved, and interacted. When you look at an image of a distant quasar, you are seeing light that began its journey. Before Earth existed, a message from the universe's youth, still arriving now. Shadows in the light. Sometimes, as a quasar's light travels toward us, it passes through clouds of gas or dust between galaxies. These clouds absorb specific wavelengths, leaving dark lines in the spectrum, like fingerprints. By studying these absorption lines, astronomers can learn about the composition, temperature, and movement of the intergalactic medium. Thus, even the shadows in a quasar's light become sources of knowledge. Every dimming of brightness tells a story about what lies between us and the beginning. Windows into the dawn. Because quasars are so ancient, they act as windows into the early universe. Their light allows us to peer back more than 13 billion years to a time when galaxies were first assembling. Through them, we can trace how matter organized, how the first black holes grew, and how the cosmic fog of hydrogen was lifted. To study a quasar is to look into a mirror of time, to see the universe not as it is, but as it was at the moment it began to think. Letters from the ancient universe. Every photon from a quasar is a message, a letter written in light, sent across billions of years. Some began their journey when our galaxy did not yet exist, crossing the expanding universe to reach us now. In each ray lies a record of conditions long vanished, a fragment of cosmic memory. When we detect them, we are not merely observing, we are receiving. The universe, through quasars, writes to us, telling the story of its awakening, of how light first learned to outshine the dark. Galaxies spin too fast for visible matter. When astronomers measured how galaxies rotate, they found something strange. The outer stars were moving too. Fast, far faster than gravity from visible matter could explain. According to the laws of physics, those stars should have been flung into space. And yet, they remained bound, orbiting in perfect balance. The only explanation was that an unseen mass, something invisible, was providing the extra gravity. Thus began the mystery of dark matter, the hidden weight of the universe. The hidden mass we cannot see. To explain these unexpected speeds, scientists propose the existence of dark matter, a vast, invisible substance that interacts only through gravity. It does not emit light, absorb it, or reflect it, yet it outweighs all the stars, gas, and dust combined. It is the invisible hand that shapes galaxies, keeps clusters intact, and defines the structure of space itself. We cannot see it directly, but its fingerprints are everywhere, in the motion of galaxies, the bending of light, and the quiet persistence of form. Most of the universe is invisible. Dark matter makes up about 85% of all matter in the universe. Ordinary matter, everything we can touch, measure, or see, accounts for less than 1/6 of reality. That means most of the universe is invisible, composed of something we have never directly detected. We are surrounded, supported, and even defined by what we cannot see. The universe, it seems, hides the majority of itself behind a veil of gravity, seen only through its pull. Dark matter neither shines nor absorbs light, but we can see its influence in how galaxies behave. It bends the paths of photons, a phenomenon known as gravitational lensing, magnifying distant galaxies and distorting their shapes. It binds clusters, guides motion, and forms halos around galaxies. We observe its effects the way we sense the wind, not by seeing it, but by watching what it moves. Dark matter is the gravity of the unseen, silent, shadowless, and untouchable. Unlike normal matter, dark matter does not interact with electromagnetism. No light reflects from it. No radiation escapes it, and no detector has yet captured it. It passes through ordinary matter as though it isn't there, like a ghost moving through walls. Billions of dark matter particles may be streaming through your body right now, unnoticed, undisturbed. We exist within it, yet we cannot feel it. It is the quietest presence in the cosmos, everywhere and nowhere at once. The invisible halo around every galaxy. Each galaxy, including our own, is wrapped in a halo of dark matter, a vast, spherical region extending far beyond the visible disk. This halo contains most of the galaxy's mass and acts as its gravitational skeleton. Without it, the galaxy would tear itself apart as it spins. We cannot see this halo, but we can trace its outline through the motion of stars and gas. Like a shadow that gives shape to light, dark matter surrounds every galaxy, defining its form from the unseen, holding the galaxies together. Without dark matter, galaxies would not hold together. Their outer stars would escape, their disks would unravel, and their clusters would drift apart. Dance. The stars, beautiful as they are, owe their order to the darkness that holds them in place. Clusters bound by the invisible. Galaxy clusters, too, owe their coherence to dark matter. Observations show that the visible galaxies and hot gas within them cannot account for their total mass. Only the presence of dark matter explains why these massive structures stay intact. It fills the space between galaxies, shaping the cluster's gravitational field. Even when galaxies collide, their dark matter halos pass through each other, continuing their silent journey. It is the invisible architecture of the cosmic city, the skeleton of the cosmic web. On the largest scales, dark matter forms the framework of the universe. It gathers along filaments, creating a vast cosmic web, the underlying skeleton upon which galaxies and clusters assemble. Ordinary matter follows where dark matter leads, condensing along these threads of gravity. Every supercluster, every galaxy, every star exists because dark matter drew the outlines first. It is the unseen geometry of creation, a lattice of gravity that defines all structure in the cosmos. As it grows, discovered in the late 1990s, it overturned our understanding of cosmic destiny. Instead of slowing down, the universe is speeding up, stretching space itself faster with time. Dark matter shapes, dark energy separates. Together, they form the dual heartbeat of the cosmos: contraction and expansion, gravity and flight. The dominant force of the universe, dark energy, accounts for roughly 68% of the total energy of the universe. Dark matter contributes about 27%. That leaves less than 5% for everything else: all stars, planets, and atoms. In the cosmic equation, we are the smallest part. The universe is not made mostly of matter, but of the unknown, energy we cannot see, filling every corner of space, driving it ever outward. The accelerating expansion. Before dark energy was discovered, scientists assumed gravity would eventually slow the expansion of the universe. But distant supernovae told another story. They appeared dimmer than expected, meaning they were farther away. Proof that expansion was accelerating. Something was pushing the universe apart. That something is dark energy. It acts not between galaxies, but within space itself, stretching the fabric of the cosmos. The universe, it turns out, is not coasting. It is quickening, quietly, everywhere. The mystery without a name. We do not know what dark energy truly is. It may be an unknown field, a new property of gravity, or simply the energy of empty space. Einstein once called it the cosmological constant, a term he later regretted, though perhaps he was right all along. Whatever its nature, dark energy behaves like an invisible pressure, pushing galaxies apart. It is the universe's most profound mystery, a force that cannot be seen, yet defines the fate of everything. The energy of space itself. One idea suggests that dark energy is the energy of space itself, that even a perfect vacuum is not truly empty. Quantum physics tells us that space constantly flickers with virtual particles, appearing and vanishing in less than an instant. If this restless energy adds up across the universe, it could explain the observed acceleration. In that case, dark energy is not outside of us. It is within every point of space, including the air around you, the ground beneath you, and the silence between the stars. The two forces that shape fate, dark matter and dark energy, are opposites, yet together they define the destiny of the universe. One gathers, one disperses. Their delicate balance determines whether the cosmos will expand forever, slow and collapse, or approach some quiet equilibrium. At present, dark energy dominates, ensuring eternal expansion. But gravity never fully fades. It holds galaxies, clusters, and stars in place, forming islands of order in a sea of acceleration. The universe's fate is written in this balance of invisible powers, the push and pull of existence. You can imagine dark matter and dark energy as the inhalation and exhalation of the universe. Dark matter pulls everything inward, condensing light into stars, stars into galaxies. Dark energy pushes outward, stretching space, giving the cosmos room to grow. Together, they create a rhythm, a cosmic breath, so slow that one cycle lasts billions of years. In that vast breathing, everything that exists takes part. Each photon, each atom, each living thought suspended in expansion. The universe's silent breath. This dance of gravity and expansion is not skeleton of dark matter. It is as if the universe itself is alive, inhaling, exhaling, expanding, holding, in a balance between stillness and motion. And through it all, light continues to flow, carried gently within this unseen rhythm. Two faces of one mystery. Some physicists wonder whether dark matter and dark energy might be two aspects of the same phenomenon, different expressions of a single cosmic substance. Perhaps under certain conditions it clumps, becoming matter. Under others, it spreads, becoming energy. If true, then the universe's dual nature, its gathering and its expansion, may be one act, seen from two directions. Darkness, then, is not absence, but unity, the hidden symmetry beneath all things. Every galaxy woven into the unseen fabric. Every galaxy floats within a web of invisible matter and expands within a field of invisible energy. We are bound by one and carried by the other. The stars we see are only the embroidery on this hidden fabric. Luminous patterns woven upon darkness. Without the unseen, the seen could not exist. Every beam of light travels through a sea of shadow. Every act of creation anchored by the quiet presence of what cannot be touched. Darkness keeps the light alive. Without the unseen matter and energy, the universe would collapse or fly apart. It is darkness that grants light its place, that gives galaxies shape, that gives time its direction. We often fear the dark because we cannot see within it. Yet in the cosmos, darkness is the source of balance. Every shining star, every glowing galaxy, owes its existence to the gravity of the unseen. The light of the universe endures because the dark allows it to. Every galaxy has a life story. Like stars, every galaxy has a life cycle, a cosmic biography written across billions of years. Some are born in turbulence, others in calm. Some live brilliant, active lives, while others drift quietly in the dark. They gather matter, form stars, collide, and transform. Their shapes and colors change, their light waxes and wanes. Each galaxy is a story of evolution, an organism of light, growing and aging in the flow of time. From youth to stillness, young galaxies are energetic and vibrant, full of gas and dust that give birth to countless stars. As they mature, star formation slows. In old age, the gas runs out. The light softens, and the galaxy grows dim. The transition from blue to red, from motion to calm, mirrors the aging of life itself. Each galaxy, like a living being, moves from the fire of youth to the serenity of age, the frenzy of star birth. In their youth, galaxies experience periods of intense star formation. Gas clouds collapse rapidly, forming clusters of hot, massive stars that burn bright and short. This era, often called the starburst phase, shapes the galaxy's early structure. The light is bluish, energetic, full of ultraviolet radiation. For a brief cosmic moment, the galaxy shines like a jewel, a storm of creation before the quiet years set in. The slow fading of age. Over time, galaxies consume or lose their gas. Supernova explosions, stellar winds, and black hole activity blow material into intergalactic space. Without fresh gas, new stars cannot form. The old stars cool, redden, and die. The galaxy's brilliance fades, its shape softens, and its color turns warm and quiet. What remains is an ancient city of stars, beautiful still, but no longer alive with birth. The quiet of elliptical galaxies. Elliptical galaxies are often the final stage of evolution. They are filled with old, red stars and little to no gas. Their light is steady but subdued, a soft, golden glow from countless ancient suns. They are the cemeteries of cosmic youth, where motion has slowed and chaos has found calm. Yet even here, there is dignity, a grandeur and rest, as if the galaxy has found peace after eons of creation. Rebirth through collision. Sometimes, an old galaxy finds new life through merger. When two galaxies collide, their gas clouds are compressed, reigniting star formation. For a time, the galaxy glows with renewed energy, blue and brilliant once more. In this way, death gives rise to rebirth. Even in the universe, endings are rarely final. They are transformations, cycles of matter returning to motion. The influence of central black holes. At the heart of every massive galaxy lies a supermassive black hole, and its behavior profoundly affects the galaxy's fate. When it feeds, its outflows can heat or blow away gas, halting star formation. When it sleeps, the gas cools and stars can form again. Thus, a galaxy's evolution depends not only on its stars, but also on its invisible heart, the quiet regulator of its destiny. Feedback, the galaxy's self-regulation. The energy released by an active galactic nucleus, AGN, creates feedback, powerful winds that shape the galaxy's future. These outflows can stop new stars from forming by pushing away cold gas. In this way, the galaxy controls its own growth, preventing itself from burning out too quickly. What looks like destruction is actually balance, a self-regulating system ensuring survival through moderation. The universe's changing colors. Over cosmic time, the population of galaxies has shifted. Billions of years ago, the universe was filled with blue, star-forming galaxies. Today, most galaxies are red and quiescent, their star-making days behind them. Astronomers call this change cosmic downsizing. The universe itself is aging, its youthful glow fading into a warm afterlight, the color of memory. Growing density of clusters. As time passes, galaxy clusters become denser. The galaxies within them move closer together, merging and stabilizing under gravity. The universe's large-scale structure becomes more defined, its web tightening. But as dark energy accelerates expansion, these connections will one day begin to loosen again. For now, the clusters are like cosmic metropolises, busy, massive, full of ancient light and quiet motion. The coming stillness of expansion. As dark energy continues to dominate, galaxies will drift farther apart. Gravitational interactions will become rare, mergers will slow, then cease. Eventually, every galaxy will be alone, its neighbors receding beyond the horizon of visibility. The universe will grow quiet, each island of light isolated in its own space. What once was a cosmic dance will become a still sea, expanding, but empty of connection. The age of loneliness. In that far future, galaxies will no longer meet. The night sky of each world will fade as other galaxies slip beyond the limits of sight, carried away by accelerating expansion. Observers, if any remain, will see only their own galaxy, suspended in darkness. The universe will become a collection of solitary lights, drifting endlessly apart. It will be the age of cosmic solitude. The last companions. As eons stretch on, galaxies themselves will begin to fade. Their stars will age, die, and cool into faint embers. No new stars will form, no new light will be born. Each galaxy will become a quiet relic, a graveyard of ancient suns. And yet, within those faint remnants, gravity will still whisper, holding what remains together a little while longer. The long twilight of stars. After trillions of years, the last bright stars will burn out. What remains will be red dwarfs, glowing dimly for billions more years, until even they fade. The universe will enter a dark age where the only light comes from cooling white dwarfs and occasional flashes from dying neutron stars. It will be a twilight without dawn, the slow cooling of all. Radiance. The long sigh of creation, the cold and the quiet. In the distant future, galaxies will become cold and dark. Stars will die, dust will freeze, and black holes will dominate. The temperature of the universe will drop toward absolute zero. Space will be vast and empty, matter scattered and slow. The cosmos will rest, not in destruction, but in stillness. It will be the final breath before eternal silence. The reign of black holes. As stars fade, black holes will remain, the last rulers of a dying universe. They will drift through the dark, swallowing remnants of matter, merging occasionally in deep silence. Each will grow, then wait, surrounded by nothing but the faint glow of fading particles. For ages, they will hold dominion. Patient, cold, and inevitable. The slow evaporation. Even black holes are not forever. Through a process known as Hawking radiation, they slowly lose mass, emitting faint energy over unimaginable timescales. Small ones vanish first, giant ones last the longest. Eventually, after 10 superscript 1 years, even the largest black holes will evaporate, leaving behind only a whisper of their existence. A final shimmer before the void. The last light. When the last black hole fades, the universe will be dark once more. No stars, no galaxies, no light. Only the faint echo of background radiation, stretched into wavelengths larger than the cosmos itself. Time will continue, but nothing new will happen. It will be a universe without witnesses, where silence reigns supreme. And yet, in that silence, the memory of everything that ever was will remain, written into the curvature of space-time itself. Memory in the fabric of time. Even when all light fades, information endures. According to physics, energy and data are never truly lost, only transformed. The structure of space-time will still carry the faint imprint of every star, every motion, every life that ever existed. The universe remembers, though no one remains to recall. It is a memory written not in words, but in geometry, the quiet persistence of being. The eyes that look back. And perhaps, the universe remembers through us. For we are made of its dust, shaped by its gravity, and lit by its stars. When we look up at the night sky and wonder, we are the cosmos becoming aware of itself. Our thoughts, our questions, our awe, these are not separate from the universe, but its reflection. Even when the stars fade, the memory of their light endures, in our minds, and in whatever follows. For as long as there are beings who can look upward, the universe will never be truly dark. Galaxies as neurons, the universe as a brain. Across the cosmic web, galaxies connect through filaments of matter, glowing nodes linked by threads of gravity. When seen in full, this structure looks astonishingly like a neural network. Each galaxy, a neuron. Each filament, a synapse. Together, they form a vast architecture of connection, a mind made of stars. Perhaps the universe is not merely expanding, but thinking, each interaction a flicker in its unimaginable awareness. Every ray of light is a signal. Each photon, traveling for billions of years, carries a message, a tiny pulse of information from where it was born. The light from distant galaxies is not random. It encodes their motion, their chemistry, their history. When it reaches us, it delivers knowledge. Every beam of light is a signal sent across time, a thread linking now with then. In this way, the universe constantly communicates through radiation, gravity, and the silent geometry of existence. Every interaction is an exchange of information. In physics, all interactions, from the pull of gravity to the spark of electromagnetism, are exchanges of information. Particles share data about position, energy, and state. Matter learns how to move, light learns where to go. Across scales, from atom to galaxy, reality is a conversation. The universe is not static. It is a continuous dialogue between all that exists, an eternal flow of information across space and time. The cosmic web as a network of awareness. The cosmic web is more than structure. It may be the pattern of a vast consciousness. Every filament channels gravity, energy, and radiation like thoughts. In a neural field, clusters ignite, galaxies evolve, stars are born, signals ripple through the network. Perhaps awareness is not confined to the brain, but a fundamental property of the universe itself, arising wherever matter organizes into connection. In that sense, the cosmos is not empty. It is awake, though in a way beyond comprehension, living within a thought. If the universe is a vast network of awareness, then we live inside a thought. Every moment, every heartbeat, every flash of insight might be part of the universe reflecting upon itself. The galaxies are its neurons. The stars, its pulses. We, its brief synapses of wonder. In contemplating the universe, we become part of its own contemplation, a single dreamer dreaming within a greater dream. The universe. Looking back, when we gaze into space, we are not just observing, we are being observed. The photons entering our eyes were born in the hearts of stars billions of years ago. By seeing them, we complete their journey. In that moment, awareness meets awareness, the cosmos perceiving itself through the lens of consciousness. We are both the watcher and the watched, both question and answer. The light of ancient galaxies as memory. The light from distant galaxies is ancient memory. It began its journey before Earth existed, carrying the story of those stars across the ages. When it reaches us, it tells of their birth, their collisions, their transformations. Each photon is a preserved instant of history, a frozen thought of the cosmos. The universe remembers through light, and in observing it, we awaken those memories once more. Photons as messages from the past. Every photon is a messenger traveling through space-time. Some have wandered for 13 billion years, passing through expanding voids, bent by gravity, stretched by time. When they reach our instruments, they deliver whispers of what once was, the color of a star, the warmth of a dawn long gone. To catch light is to read a letter from the ancient universe, and every starlit night is an archive of eternity, drifting among islands of light. As we fall asleep beneath the stars, our minds drift between islands of light, imagined galaxies born from memory and dream. Each thought becomes a constellation, each emotion a nebula of color and feeling. The same forces that shape galaxies, attraction, expansion, rhythm, echo in our inner worlds. In sleep, our consciousness mirrors the universe, expanding, connecting, and dissolving into calm infinity. Dreams as personal galaxies. Dreams are our private universes, built from light of memory and shadow of thought. They spin, collide, and vanish, just like galaxies. In them, time stretches, gravity bends, and imagination replaces physics. Each dream is a small cosmos, unique yet made of the same elements as the stars: energy, order, mystery. When we dream, we are practicing creation on a human scale, understanding as union. When we understand the universe, we are not standing outside it. We are participating in its intelligence. To grasp the motion of stars or the structure of space is to share in the cosmos's own logic. Every equation solved, every truth uncovered is an act of communion. Through awareness, the universe becomes self-aware. Understanding is not conquest, it is unity. The cycle of galactic rebirth. Galaxies are not destroyed, they transform. They merge, evolve, and renew. Matter recycled into new stars, energy reborn in new forms. The universe practices reincarnation on a cosmic scale. What once was dust becomes light again. What once was light becomes dust again. Through this cycle, the cosmos teaches the simplest lesson of all: nothing truly ends. It only changes its way of shining. The persistence of light. Light can never be truly destroyed. Even when absorbed, it becomes warmth, motion, information. Every photon that has ever existed still echoes in some form, scattered, stretched, remembered by the fabric of space. The universe keeps its light like memory keeps love, transformed but never gone. The shape-shifting of energy. Everything changes form. Energy becomes matter, matter becomes radiation, and radiation returns to energy again. The universe is a perpetual alchemy, a seamless exchange between being and becoming. There is no loss, only translation. Every change is a new sentence in the story of the same eternal substance. The whisper of existence. Every star that shines, every particle that hums, every breath that moves through space is saying the same thing. I exist. Existence itself is the quiet song of the cosmos, endless variations on one note of being. When we listen closely, we realize that we, too, are part of that whisper. We are the echo of the same declaration, made conscious. Galaxies as stories of light. Each galaxy is a story written in photons. Spirals speak of order and rotation, irregulars of chaos and youth. Ellipticals tell of endings and peace. To study them is to read an anthology of cosmic experience. The universe is a library without walls, every page glowing softly in the dark. Humanity as the listeners. If galaxies are songs, then we are the listeners, the small, fragile beings who hear them. Our telescopes are instruments tuning into the great symphony of creation. We may understand only fragments, but even fragments are enough to move the soul. To listen is an act of reverence. To wonder is to belong. The universe sings on. Even as we sleep, the universe continues its melody. Galaxies spin, stars ignite, black holes breathe in silence. Cosmic rays whisper through the void. Light crosses the abyss, and time itself hums softly. Beneath it all, the song never stops. Only our awareness drifts away for a while, resting in the rhythm of infinity. Sleep is a bridge to the infinite. Sleep is not the absence of thought. It is the return to the universal flow. When we surrender to rest, our minds dissolve into the same stillness that surrounds galaxies. In dreams, we reconnect with the wider fabric, the infinite mind of the cosmos. We are not leaving the universe when we sleep. We are returning to it, the sky that waits. And when we awaken, the sky is still there, silent, patient, eternal. The same stars, the same light, the same quiet invitation. The universe has been waiting, not to be conquered, but to be listened to. So look upward once more. Feel the calm gravity of its gaze. For in every glimmer, every faint shimmer of starlight, the cosmos whispers the oldest truth of all. You are part of me, and I am still here.